All right, so compound inequalities, we've got these two words that we're going to deal with. The first word is a conjunction. The second word is a disjunction. We're going to do conjunctions first. So we're going to come down to this first example, and we're going to say, hey, we have some important points of 3 and -1. So I'm going to circle this with red, and I'm going to put 3 up here. 2, 1, 0, -1, -3, etc. Would you agree that it's an open circle, first of all? Let's do a little review. Why open, Luke?
Because it's not equal to.
Okay, because it's not equal to. Whoops. We're going to jump back here. All right, now I want to switch to blue. I'm going to go down to this line below, and I'm going to put a filled in circle, and I'm going to shade to the right. Same number line, same points, etc. Would you agree that is a filled in circle?
Yes.
Okay, so I want you to do the magic math method here, Samantha, and we're going to take these two number lines and we're going to push them together and combine them. And my question to you, who's my color, who's my artist, people? What do you get when you combine blue with red? Purple. All right, so I happen to have purple here. So where is it going to be purple? I don't want any red, I don't want any blue, I just want, where is it just going to be purple when you combine them? Okay, so between -1, I'm going to fill that circle in, and I'm going to go up to 3, and I'm going to leave that one open. So everything between -1 and 3 is my solution. Okay? Now let me show you how to write that. Put a -1 on the left, and put less than or equal to x. What I did was, Joe, I read this one up here backwards. And then x is also less than 3. So what I've circled down here on the bottom, that's our answer to our conjunction. Grace, it's also called a compound inequality. So what's purple? I want not just one thing to be true, Luke, but both things to be true. And that's what a conjunction is. Now let's take this now and turn this into words. This says shade in all the points that are represented below. All real numbers that are less than 4. Okay, so I'm going to put a number line here. Here's 4, 3, 2, 1, 0, -2, -4. So everything that's less than 4. Okay, so we're going all the way down here. Would you agree that's less than 4? Okay, now I'm going to change colors. So that's less than 4. I'm going to go at least 0. What does at least 0 mean? 0 or what? Or more. Okay, do I include 0 in 0 or more?
Yes.
Okay, so include 0. 0 or more. So here's my real question. This is a conjunction. I need to know where they are overlapping. So I'm going to go to purple again. Where are they overlapping? Do they overlap at 0? Yep. Do they overlap at 1? 2? 3? 4? 5? So would you agree that would be my purple section? So if you have the ability, now take your eraser, erase the red, erase the blue, and what should be left? Everything that's in the middle. Now I do see one small little error there. Do you see the small error? What does less than 4 mean? Do I include 4? No. So what we're going to need to do is we're going to have to change this to an open circle and shade up to the 4. Less than. Now tell me some other words that relate to inequalities. What's the opposite of less than? More than. So what would that be associated with? Greater? Can Can you think of any others? There was one on the quiz, wasn't there? At most. What about at most? You can be at most 3 feet tall to ride on this ride in the playground. What would that be? What sign? You can be at least 3. You must be. Let's see. You can be at least. At most 3 feet tall. So it is what? 3 feet and below. Okay. Can you think of other words? How about, well, we already dealt with at least. At least is greater than or equal to. Okay. So let's write this as a compound inequality. 0 is less than or equal to x, which is less than 4. And that's our answer. Notice which kind of signs we have inequalities when we're doing a compound inequality that's a conjunction, Gigi. They're both less thans. They both point to the left. Okay, so a conjunction, a intersection thing, they both point to the left. And so we're going to write that as a compound inequality. Pretty straightforward. Let's move on. Now we're going to get out to some algebraic ones. Who feels comfortable solving this first one? W plus 5 in the middle. How do you get rid of the plus 5? All right, so let's subtract 5. But if I subtract 5 to the middle, I must also subtract 5 to both other sides. So everyone do minus 5 3 times. 4 minus 5, somebody is? Negative 1, less than or equal to W. 8 minus 5 is? 3. So let's put this through the test. Are they all less than signs?
Yeah.
Less than or equal to?
Yeah.
They're all pointing left. So this is going to be shaded where? In the middle. In between negative 1 and 3. Shade in between. Do I fill either circle in? Yeah, fill in the left one. Nice job, Luke. So algebraically, I'm going to circle my answer. There's my answer circled in red, and there's my answer graphically. Really straightforward. Making sense so far? Which way do the inequalities have to point when you finish in order to shade in between? Left. Okay? They have to point left. All right.
What happens if they don't put
Then it's not shaded in between. Then it's kind of a completely different style of problem. We'll deal with that. All right. Who wants to solve this one? Ella, you feel comfortable? How do you get rid of that plus 9? Okay, so minus 9. Just to the middle? To both sides as well. So minus 9 3 times. What's left? Negative 8. Negative 2x. Greater than or equal to negative 12. Good. All right, what's next? Be careful. Be really careful. What's next? Yeah, Noah. Divide by negative 2. Who can tell me my answer? 4. Be careful here. What did we just divide by? So Lula, what happens? Yeah, it changes the inequality. How many saw that? Let me see. Okay, so be careful there. All right, and then we have x. Does this one change as well?
Yes.
You bet it does. And that's 6. All right, so Jessica, you asked the question, what if they point the opposite way? Well, they don't on this one. Which way are they pointing? They're pointing left. They're both pointing left. So where do we shade? In the middle. So let's put them on our number line. 0, 2, 4, 6, 8. Open circle at 4. Closed circle at 6. Shaded in between. Kind of a small little graph. A tiny little section there, Samantha, that's our answer. Those are the only answers that work for both questions. So I'm going to circle our answer, our graph, and circle our final answer down here. Do you remember what the word these are called again? Starts with a C? Conjunction. Okay, these compound inequalities are called conjunctions. All right, Ella got us going on that one. Who can start us on this on number 5? Luke, you have the floor.
You have to subtract 2 on both sides.
Is that?
No,
And then also where?
in the middle.
In the middle. Okay, go ahead.
So then it's 3 is less than or equal to 3x less than 14.
Good. 3 is less than or equal to 3x.
12.
Oh, thank you. Good catch. Did you say 14?
Yeah.
Oh, okay. All right, now let me show you something that someone did last hour that caused a problem. They did that. Are you supposed to divide by 3?
Yeah.
My worry is if you divide by 3 here, you might not think to divide everything by 3. You might get a little careless. And so I want to avoid this, and instead I would really encourage you to divide each one by 3. So mentally, Christine, you can be like, divide this by 3, divide that by 3, divide this by 3. Now, obviously 3 over 3 is what? 1. Do I change the sign?
No.
Why not?
Because it's not minus.
Okay, you're not dividing by a negative. What about multiplying? When you multiply by a negative, does it also flip?
Yeah.
Okay. 3x over 3x, x, and
4.
are they pointing left?
Yes.
So where do we shade?
In the middle.
In the middle. So here we go. 0, 1, 2, 3, 4, 5, 6. If you see my mistake, please raise your hand. Wow, that was quick. Holly. Excellent catch. Excellent catch. So my answer is that and this. And once again, these are called what kind of functions? Conjunction. 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 And they are shaded where 2 things must be true. 2 things must be true. Both parts of the equations must be true. Questions? Now, if you remember back to our earlier illustration, Holly and Ann got the postcards, okay? Because how many things were true? 1 was true, at least 1. 1 or more. And so that's our next part. So let's slide down to disjunctions. Disjunctions are inequalities that are joined by the word or. They're called a disjunction, all right? And notice, the answer should be written as how many? 2. Let's flip back to the first one. The answer should be written as what? 1 continuous inequality. And these are connected with the word and they're called a conjunction. All right? So, we just need to see the difference there. So here we go. I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to circle the left one with red, and I want to graph x is less than 3. Which way do I shade? How do you remember shading to the left, Luke? What is your trigger there?
Because, well, for me, it's because the sign is right.
Okay, so it's pointing left, so you shade left?
Yeah.
Okay, so it's pointing left, so you shade left. Okay, that works. Obviously, it only works when the variable's on the left, but yeah. All right, let's circle the other one in blue. X is greater than or equal to 7. I'm going to fill in that dot, Joe, because it's equal to. And then I'm going to shade which way, folks?
Right.
To the right. There we go. On our first example, we were looking for where things cross, Noah, because they have to be true for both of them. On our second example, what are they connected with? What word? Or. Is that a more forgiving kind of word? You could be a winner if you are this, or you're that. Do we have to be both? No. So what is my answer? Very simply, that's my answer. What are the only things that don't win? that aren't solutions. Everything in between 3 up to 7. Everything else is a winner because it works for either one of them or the other one. And that's the beauty of it. Algebraically, you don't write this as one inequality. You write it just like this. That is your answer. 2 inequalities. So let's practice on these. We got 7 and 8 down here. -1, 0, 1, 2, 3, 4, 5. All right, I'm going to circle the first one in green.
How do you, like, if you have a problem,
Uh-huh.
like, if they give you a problem, how do you solve?
Oh, we'll show. I have a couple later that we're going to do some solving. So, everybody shade to the left. Because do we agree that x is less than 2? We shade to the left. Less than, go left. All right, pick a color. Blue, Samantha, red, or purple? Purple. All right. Circling with purple. I'm going to put a dot at 0. I'm going to fill in that dot, Samantha, because it's equal to. And it's pointing to the left, and it's less than, so I'm going to shade to the left. Interesting. Where is the purple part? Is it all in the green section?
No.
No.
Isn't the whole purple thing in the green?
Yes.
So did the purple give us any additional answers? No, it didn't. So I'm going to pick one final color and make it red. I'm going to put it above here. And the red is going to represent my answer. Can you give me one simple inequality for the red? X is what? Less than 2. So that's my answer. Because, Sam, all I care about is either one being true. Whether it's purple or green, I don't care. But does the red one basically cover both the purple and the green? Okay. Carol?
How would you know when there's a, like, shade or, like, dark?
To shade the what?
No, like, shade the circle.
If it's equal to?
No, like, how would you know like, that answer?
Oh, you see how this is an open circle here?
Yeah.
So therefore that's going to be an open circle there.
Okay.
Good question. Good question. All right. Moving on. I'm going to start here with red. X is greater than 4. Shade to the right. We're going to go back to purple. One of my favorite colors. Here's greater than or equal to 3. So you notice, Cairo, I just filled in that circle of 3. And which way am I shading? Okay. Uh-oh. I'm coming up to this open circle. What do I need to do to it? Fill it in. Because the purple is going to keep going, isn't it? All right. What do you think my real answer is? My final answer?
X is greater than or equal to negative.
So do you think the purple pretty much covered over everything? So this would be my real answer, something like that.
Yes.
Okay? So we have a couple possibilities here. Up here, did they cross? No, but that's okay. Down here, they kind of overlapped. And so remember, with an or statement, it's either one can be true. So Sam, either the left one or the right one, or if they're both going left or they're both going right, it's whatever is shaded is your answer for an or statement. So now let's get down to what you were saying, Jessica, about solving some. All right, Gigi or Christian or Caro, can you solve either one of these for me?
Subtract 3.
Subtract 3.
Both sides.
So 4x is less than negative 8.
And then you're going to divide it by 4.
All right, now I want to pause for a second because I had this question in my last hour. They asked me quite seriously, do I flip the sign?
No.
Because they said, but there's a negative in the problem. So how do I answer them?
It's not, you're not dividing by the.
Right, you're not dividing by a negative, so we don't flip the sign. That's great. So x is less than negative 2. So here's my negative 2. There's my shading. Beautiful. All right, so Christian or Caro, can you do the second one for us? Subtract 7. So negative 2x is less than negative 6. Christian, you want to finish it?
Divide.
Okay, divide by negative 2. Did you hear what he just said we're dividing by? Negative, right? Which means we...
Flip.
Okay, so the sign flips from less than to greater than. And that becomes a positive 3. So negative 2, negative 1, 0, 1, 2, 3, 4, 5. Which way is this one shading? To the right, to the right, to the right. Okay. So it looks like that's our answer. Do I care that they don't overlap?
No.
Oh, because what kind of function is this? It's connected with the word or. It's very important that you write that word or in your answer. So if you haven't connected your two phrases with the word or, please write that word or in between there. You know what? Let's look back up. Let's see if we did that on our others. We don't need it here, do we?
No.
And here we have the word or already typed in. So we're good. So we need to write the word or in between our functions. All right, thank you, our threesome. All right, next up, we're going to go with Anne and Caroline and Lulo. Lulo, we're going to let the ladies go first to be gentlemen. So, Anne and Caroline, which one would you like to do first? The left one or the right one? The left one. Okay, go ahead. How much? Subtract 8. So negative 3x is greater than negative 6. Keep going. Divide by negative 3, and if you didn't hear her, she said flip the sign. Okay. Anne or Lulo, go ahead and do the other one. Annie. Let's go Branson or Lulo. Go ahead.
Plus 4 both sides.
Plus 4 to both sides. So 3x is greater than or equal to 9.
Divide by...
Do I flip the sign?
No.
Good. All right. So I've got 2, 3, 4, 5, 6, 1, 0. The blue part was everything less than 2. The purple part was everything greater than or equal to 3. Did we connect our inequalities with the word or? We did. So there we go. Do I care that they cross?
No.
No, because this is a disjunction. And Alyssa, it doesn't matter. It's either this one or that one. Now, if you'll notice on this one, there's a very, very, very small margin of numbers that actually don't work. What are those numbers that don't work? Just from 2 up to 3, right? A very small window that otherwise almost anything you pick would work. Okay, down to our humdinger, our challenge problem. Tell me about this inequality. Does it look like it's shaded in between, or does it look like it's shaded kind of out? In between. So, from what we just learned, is this a conjunction or a disjunction?
Conjunction.
Conjunction. Do you remember what kind of inequalities a conjunction has? Okay, it's an and statement. Yes, it is an and statement. Which way do the inequalities point?
To the left.
To the left. Okay, so we have this point right here looks to be negative 2. So let's just write negative 2 is less than x is less than or equal to, y equal to? Okay, or equal to 3. Does that make sense? Because why is it equal to? Because it's a filled in dot. All right, and it's a conjunction. Notice how many inequalities do we write a conjunction with? Just one. Caro?
How would you know?
Well, if it's shaded in between, it's going to be one inequality. written just like this with a conjunction. If it's shaded out, then it's going to be an or statement.
So like, are you not just like left or right?
In terms of which direction to shade?
Yeah. No, like now I got less than.
Oh, less than points left. And any conjunction will always have less than signs. If it's shaded in between, it's always going to have a less than sign. Okay? All right. Any questions other than that? Okay. All right. We've got a short homework assignment. Go ahead, Joe.
Sure. So, did everyone, so when will we have to post?
Oh, it's online.
Is the book online?
The book is online. We officially did it.